Can touching any hardware inside a running PC be dangerous for you? I'm curious, if all the hardware gets power from the SU's DC power lines, which provide a max voltage of 12V, can you get electrocuted by touching some of the hardware?
The short answer is no. 12 volts isn't high enough, and the 24 rail-to-rail voltage available is from an unbalanced pair of connections. 12V is pretty limited on current output. The long answer is yes. A faulty power supply with a bad ground connection, third prong, can kill you. Older machines ran mains power up to the on/off switch, and a hot wire laying over a sharp edge could put full mains power on the chassis. But then the system doesn't have to be open, just touching the metal case would do it. While you hear about the occasional electrocution from computers in the news, bad ground circuits, the likelihood of working on an open system harming you is extremely low to nil. Now where you get into trouble is working with old CRT monitors. The flyback transformer system output starts at about 8.000 volts, and the tube is a neat Leyden jar, just waiting to bite when fingers get into the wrong areas and kill when the current travels from arm to arm. Having taken 80 kV from a General Motors Hay ignition system, I can tell you from experience you don't want to do this. LCD backlight systems also are another area to avoid, as you're dealing with 9400V depending on the system. Protecting the system from you often is more likely to be an issue. Having drawn a 1-inch static spark on a motherboard once and not having anything happen for me was a stroke of luck. Ground straps are probably a good idea. Update on human physiology. Grab an ohm meter with auto-ranging and perform the following experiment. With dry hands, put it on a fairly high setting with a lead in either hand and the test probes in contact with the backs of your hands. Note the resistance. Now hold the probe tips between your fingers and slowly squeeze. Get some salt water, soak your hands and hold the probe tips in your fingers. Note now the resistance changes. Most people don't understand Ohm's law, voltage divided by resistance equals current. So a 5-volt power supply capable of 50 amps is only able to push 0.0025 amp through a 2000 ohm resistance. 110 volts can push 0.055 amp through 2000 ohms, and 1000 volts can push 0.5 amp through 2000 ohms. The general test for body impedance is from arm to arm, across your heart. People have died from as low as 32 volts. The usual accepted lethal current is 0.100 amp, 100 milliamps, and is determined by voltage applied, skin resistance and the path it takes through your body in an attempt to find its opposite polarity or ground. Basically the rule is 100 mA for fib and 200 mA for total heart contraction. And the reason static from the carpet doesn't kill you is because while you have a tremendous voltage buildup, there isn't enough charge there, quantity of electrons, to carry a sustained current. Power supply systems on the other hand are designed to do this.
One tip: if you happen to be working in an older, pre-ATX computer, the wires going to and from the switch on the front of the case are carrying the same voltage as the electrical outlet. I shocked myself several times brushing up against the connection between the switch and the wire when the plastic guard had gotten dislodged. I believe this goes back to the original PCAT power supply design with the switch integrated into the supply. When they decided to move the switch to the front of the case, the simplest thing to do was to run the 120/240V power to the switch and then back to the power supply.
Yes, there is a chance to be injured. 1. You can get burned badly by a CPU, especially laptops. 2. Direct contact, for instance if a sharp a solder joint penetrates the skin, allowing good contact and low resistance, with as little as 20 mA can stop or cause fibrillation of the heart. I once touched a 12V solenoid and it caused me to accidentally hit my face with my wrist hard. D. Assuming that the power supply is 100 watts for each rail. Assuming that the power supply is 600 watts for each rail. Ever licked a 9V battery to test it? Low voltage can be quite shocking. Smile. Quoting Fiasco Labs. Human physiology. Grab an ohm meter with auto ranging and perform the following experiment. With dry hands, put it on a fairly high setting with a lead in either hand and the test probes in contact with the backs of your hands. Note the resistance. Now hold the probe tips between your fingers and slowly squeeze. Get some salt water, soak your hands and hold the probe tips in your fingers. Note now the resistance changes. Fiasco Labs. 3. Accidental contact with fan. I did this before, it hurts.
You can get burned on a hot heat sink. You can get a finger nicked on a fan blade. If you're wearing any jewelry, you can get a ring or watch band or what have you between the main 5V supply and ground. There is enough current there to cause serious burns, perhaps enough to cause loss of a finger if, e.g., your ring gets heated to red hot. In general, modern desktop power supplies are sufficiently current limited that the chance of serious injury is minimal, but in a high-powered box the 5V supply is still delivering enough current to produce this sort of hazard. It is really a hazard in big iron boxes where hundreds of amps are available, and where safety rules demand that all jewelry be removed before working inside. If you're wearing any jewelry, you can get a ring or watch band or what have you between 2 points in the circuit and burn out a $500 component, after which you'll kill yourself.
If you're not comfortable using on that, the other has very